Namaste viewers, I am Punit, a GRE instructor at Millionaire GRE. Through this video series, we are covering everything about permutations and combinations for the GRE. This is the second video of the series. If you have not watched the first video, please go through it before you watch this video. In the previous video, you were given some questions to go through. First, we will solve those questions and then we will cover some new content.
Welcome to another year at Hogwarts.
Let's solve the first question. You are given that there are 8 chasers and 6 beaters, out of which you have to select 3 chasers and 2 beaters. Now let's say you select 3 chasers as ABC. Now selecting ABC is same as selecting BAC, is same as selecting CBA. All of these form the same group. So your order does not matter. ABC is same as BAC, is same as CBA. Order does not matter. Whenever you are selecting R items out of N items and order does not matter, you apply the formula for combination. So 3 out of 8 can be chosen in 8 C3 ways. If you do not understand this, please go through the previous video. Similarly, 2 beaters out of 6 beaters can be chosen in 62 ways. Also, AND means multiplication or means addition. So you have to select 3 chasers and 2 beaters, hence you will multiply. Now when you apply the formula and solve for these 2, you will get the answer as 840, and that's your final answer.
Let me introduce you to your new defense against the dark arts teacher. Me, Gilderoy Lockhart.
Let's do the second question now. You're told out of 15 professors, a panel of 4 is to be chosen. So the total number of professors is 15, N is 15, and you require 4. R is 4. If we read further, we get that Lockhart refuses to participate. So we are selecting these 4 teachers out of 14 teachers, not 15, because Lockhart cannot be selected. Now if we read further, we get that Lupin is obligated to be a part of it. Think of it in this way, that Lupin is already a part of the panel. Lupin is already in the panel. So you are not selecting 4, you are selecting for the remaining 3 slots. You are selecting only 3 out of 13 because Lupin is already there. So out of 14, one person is already there. You are selecting the 3 out of the 13 professors available. So the question finally boils down to this, that out of 13 you have to select 3, which can be done in 13 C3 ways. If you solve, you will get the answer as 286. Now let's learn something new, and that is arrangement of numbers. Principle of counting as a concept we have covered in the previous video. Principle of counting is nothing but breaking down a bigger task into smaller component tasks. Or in simpler terms, it is making the slots and filling up the slots. Principle of counting has various applications. One of the applications is in the questions which asks us to arrange numbers. There are 4 steps that you have to follow if the question is about arrangement of numbers. The first step is to make the required number of slots. That means if you are asked to count the number of 3-digit numbers, you will make 3 slots because it's a 3-digit number. And you have to check how many ways are there to fill up the first slot, and how many ways are there to fill up the second slot, and how many ways are there to fill up the third slot. The second step is that 0 cannot be in the first place, because if 0 is in the first place, it no longer remains a 3-digit number. 067 is a 2-digit number, not a 3-digit number. The third step is to check whether repetition of digits is allowed. So you have to check whether 667 is a feasible digit according to the question. Does the question allow the repetition of digit or not? Fourth step is to proceed from left to right unless some condition is given. So that means you will first fill up the first slot, then the second slot, then the third slot, unless some other condition is given. Let's explore this through some questions. Let's solve this question in which you are asked how many 4-digit positive integers can be formed using the digits 0, 6, 7, 8, 9 such that all digits are distinct. We will follow the 4 steps that we just learned. The first step is to make the required number of slots. It's a 4-digit number, so we will make 4 slots. 0 cannot be in the first slot, because if 0 is in the first slot, it becomes a 3-digit number. Check whether repetition is allowed. Repetition is not allowed because all the digits are distinct. And the last step is proceed from left to right unless some other condition is given. There is no other condition given, so we'll proceed from left to right. Now in the first slot, 0 cannot be there, but the remaining 4 digits can be there. 0 cannot be there, 6, 7, 8, 9 can be placed in the first slot. So 4 can be there in the first slot, and in the second slot, since the repetition is not allowed, the digit which is in the first slot cannot be repeated. So out of the 5 digits, 1 digit cannot be repeated. So the remaining 4 digits can come. And in the third slot, the 2 digits which are in the first 2 places cannot be repeated. So out of 5 digits, 2 digits cannot be there. So remaining 3 can be here. Now 3 digits are already present. So remaining 2 digits can be in the last place. So the answer here is 96. Let's solve the second one. Here repetition is allowed. It's the same question, but repetition is allowed. We'll make the 4 slots. 0 cannot be there in the first slot. You check whether repetition is allowed or not. Repetition is allowed. You proceed from left to right. Unless some condition is given, there is no other condition given. Right? So let's fill up the first place. In the first place, 0 cannot come. 6, 7, 8, 9 can be placed. So any of the 4 digits can be here. In the second place, any of the 5 digits can be there. Similarly, in the third place, any of the 5 digits can be there. Here also any of the 5 digits can be there. So total there are 500 positive integers that you can form. Let's do the third one, C part. Units digit is odd. Again, it's a 4-digit number. We will make 4 slots. We're following the same 4 steps. 0 cannot be in the first slot. Check whether repetition is allowed or not. Repetition is not allowed because the question mentions without repetition. Fourth step is to proceed from left to right unless some other condition is provided. There is another condition provided that units digit is odd. So first we will take care of that condition and then move from left to right. So in the units place, any of 7 and 9 can come. So there are 2 possible ways to fill up the units place. Now that we have taken care of the condition, we can move from left to right. In the first place, 0 cannot come and the digit which is in the units place cannot be repeated. So out of 5 digits, 2 digits cannot come. So the remaining 3 can come. In the second place, the digit which is in the units place and the digit which is in the first place cannot come. So out of 5 digits, again 2 digits cannot come. Remaining 3 can come. In this place, the 3 digits which are already placed cannot come. So the remaining 2 digits can come. The answer is 36.
Let's go.
Okay, now that we have looked at arrangement of numbers, we will now learn arrangement of objects. Before we get into the concept, you are advised to remember 2 things. That n different objects can be arranged in a straight line in n factorial ways. Similarly, n different objects can be arranged in a circle in n-1 factorial ways. For instance, if there are 3 objects RON, there are 3 factorial ways of arranging RON. Right? This is what you get using principle of counting. Let's see how. There are 3 letters, so draw 3 slots. In the first slot, any of the 3 letters can be placed. In the second slot, any of the remaining 2 letters can be placed. In the last slot, the remaining 1 letter will be placed. This is nothing but 3 factorial, and the value of 3 factorial, which is 3 times 2 times 1, is 6. So there are 6 different ways of arranging RON. Even if we list down all the words you can form using RON, you will get exactly 6. Let's do it. RON is one, RNO is another, NOR, NRO, ONR, and ORN. These are all the 6 words you can form. You can have no other word with RON. So right, let me reiterate, n different objects can be arranged in a straight line in n factorial ways. Similarly, n different objects can be arranged in a circle in n-1 factorial ways. Let's have a look at few other examples. If you are asked how many different words can you form using HARRY, there are 5 objects or 5 letters. They can be arranged in 5 factorial ways. But see here, R is repeated twice, R is present twice. Hence you will divide by 2 factorial. Okay, since R is present twice, you will divide by 2 factorial. 5 factorial is 120, 2 factorial is 2, answer is 60. You can have 60 different words using HARRY. If you are asked how many words can you form using the letters of Harry Potter, let's do it. There are 11 letters in total, so 11 objects can be arranged in a straight line in 11 factorial ways. Here R is present thrice, 1, 2, 3. R comes 3 times, and T is present twice. Since R is present thrice, you divide by 3 factorial. Since T is present twice, you again divide by 2 factorial. This is your answer. 11 factorial upon 3 factorial into 2 factorial. These many different arrangements of Harry Potter can be there, or these many different words you can form using the letters of Harry Potter. So let me reiterate. N different objects can be arranged in a straight line in n factorial ways. N different objects can be arranged in a circle in n-1 factorial ways. We get this using principle of counting, and you are advised to remember this.
Racing Brew. Wow, look at it! The new Nimbus 2000! It's the fastest model yet.
Let's have a look at a few questions which involve arrangement of objects. In this question, there are 6 broomsticks and 6 wizards. In how many ways can each wizard fly solo without sharing a broomstick with another wizard? Let's say this is broom 1, broom 2, broom 3, broom 4, broom 5, broom 6. Now how many wizards can be on broom 1? Any of the 6 wizards? On broom 2, any of the remaining 5 wizards can be placed. On broom 3, any of the remaining 4 can be placed. Here any of the remaining 3, any of the remaining 2, 1. This is nothing but 6 factorial. If you know the formula that n different objects can be arranged in a straight line in n factorial ways, you can directly give the answer as 6 factorial. Because 6 broomsticks and 6 wizards are there, 6 wizards can be placed on 6 broomsticks in simply 6 factorial ways.
Sorry about that.
Okay, let's do another question. In this question we are asked, in how many arrangements of the word Hagrid are all vowels together? So let's write the vowels together, A and I, and let's take A and I as one object. If A and I form one object, there are 4 other objects, H, G, R, D. In total, we have 5 different objects. 5 different objects can be arranged in 5 factorial ways. A and I are 2 distinct objects. They can be arranged among themselves in 2 factorial ways. 5 factorial is 120, 2 factorial is 2, the answer is 240. You can have 240 different words using the letters of Hagrid in which vowels are always together. Right? Now let's look at the second one. Vowels are not together. If from the total words that we can form using Hagrid, we subtract all the words in which vowels are together, we will get all the words in which vowels are not together. Again, from the total words, if we subtract all the words in which vowels are together, we will get all the words in which vowels are not together. Let's find the total words we can form. Hagrid is a 6-lettered word, so we can have 6 factorial words. 6 objects can be arranged in 6 factorial ways. The total 6 factorial words. 6 factorial is 720. We have already calculated all the words in which vowels are together, and that is 240. 720 minus 240 is 480. Now in 480 arrangements or in 480 words, the vowels are never together. Now these are some additional practice questions for you to try. Solve them and make sure you let me know the answers in the comment section. In the upcoming video, we will discuss the solutions. As a parting thought, let me tell you that if you feel you need guidance about other aspects of the GRE, feel free to reach out to us over our website or through the contact number given in the description. Thank you and have a nice day.